In Section B, students bridge from observing patterns that grow quadratically into writing quadratic expressions to represent the patterns of growth. Next, they observe the pattern in real-life examples of free-falling objects whose height over time can be modeled with a quadratic function. They use tables, graphs, and equations to describe the movement of these objects, eventually looking at situations where a projectile is launched upward. Then, from projectile motion, students move on to examine other situations represented by quadratic functions, including area and revenue. Note that multiple representations are used to scaffold and guide student thinking as this section continues to address the Readiness Standard 7A and starts to talk to students about the domain of quadratics, which is TEKS 6A, another readiness standard. In addition, the concepts from Units 4 and 5, linear functions and exponentials, are mixed into the activities so students have a chance to constantly review and deepen their understanding of that material as well. So instructionally, in Section B, this is where students are expected to start mastering how to write quadratic functions from the tables or graphs. When helping students work with tables, I really stress their use of thinking about what stays the same and what changes. It helps them to identify what values are squared and what value remains constant. A nice example of this is in the second activity of the unit's third lesson. In this activity, students are led through the process of determining the equations for patterns occurring in square-like snowflakes and then among the columns and rows of growing rectangles. I want you to also be prepared to analyze each student's response because different students see things differently, and that means they may come up with different expressions. But taking a little time to simplify each student's responses will demonstrate that they all simplify to be the same. I would also spend time discussing the comparison between quadratics and exponentials from the video in the fourth lesson of the unit. In this video, where students compare quadratic and exponential functions, you're permitted a chance to ask students when the quadratic function is greater in value than the exponential, and vice versa. Doing so allows you to reinforce the TEKS about domain and range, both graphically and tabularly. One more thing about this section. It provides a great opportunity for a cross-disciplinary lesson as explicitly addressed in Lesson 5 of the unit. Here, students use math to investigate the science of the path of a projectile defined by a quadratic function. In the general form, ax squared plus bx plus c, the a represents half of acceleration. And for projectile motion, this is acceleration due to gravity. Thus, students often encounter gravity measurements such as negative 9.8 meters per second squared or negative 32 feet per second squared. And that results in a values of negative 4.9 and negative 16. The b value always represents the initial velocity the projectile is thrown at, and the c value is the height from which it is thrown. But be sure to notice that some of the examples refer to the distance a dropped object travels, going down. In these cases, the acceleration or measure of gravity does not use the negative sign. Science classes often emphasize the requirement of the negative sign, but students must take into account what is being measured so as to determine if the negative is needed or not. In other words, they have to consider the point of view of the measurements.